Okay, so I hope all of you remember what we have discussed in the last class. Yes or no? Hello, am I audible?
Yes, sir.
Okay, so you recall what we have discussed in the last class? Okay, so is the screen visible?
Yes, yes, sir.
Yes, sir.
Okay, so in the previous classes we have discussed about the different nomenclature of gear. Okay, the different gear terminologies there, like what is addendum, phase width, circular piece, to thickness, etc., etc. With a space, which particular this is top plane, this is the face portion, this is the flank portion, etc. All those things we have discussed, and we have seen like how these are important. Okay, and how those different parameters can be utilized, or what is the understanding of that. Similarly, like we have also discussed in details about the backlash. What is that? We understand like what is the requirement of, is there any requirement of backlash, or there is no requirement of backlash, or what happens if there is like excessive backlash and all. Okay, so some meson is being lost. So those are kind of uh, disadvantages thing with backlash. Okay, all those things we have discussed. Then we have seen one very important terminology, that is the module. Okay, it was the ratio of the pitch diameter in millimeter to the number of teeth. So module, okay, that will be in millimeter. Okay, pitch diameter in millimeter you consider, just understand that. Okay, and this is the SI unit in place of diametral piece. We will not be generally using diametral piece, but sometimes if this is also being asked, then from there you can find out the module also. Then the gear ratio, what you understand by velocity ratio, etc. Then the later on we have discussed about the law of gear, which gives you the condition which must be fulfilled by gear tooth profile so as to maintain a constant angular velocity ratio between the two gears. There we have seen like along the common tangent there can be like velocity, and really that is the nothing but the velocity of sliding, and along the common normal generally we don't want any kind of relative velocity, because of that if there is any relative velocity, either the gear to which should be in normal contact. Okay, they will either try to penetrate into each other, or they will try to like move away from each other depending on in which direction the relative velocity is. Then we have also discussed about the different forms of gear, like the cycloidal tooth profile as well as involute tooth profile. So I told you to go through in details about these two, and later on we have discussed about path of contact, arc of contact, different angles like angle of action, pitch angle. Okay, those things we have discussed, and then we have found out like what we understand by contact ratio, how it is given. That is the number of teeth in contact. It is given by contact ratio is arc of contact divided by the circular pitch. And we know that now for proper context, like the contact ratio should be like it's always greater than one. Okay, at least one pair of tooth has to be in contact for proper motion transfer. Then we have seen there is one problem that is generally there, which might be there in relation to invalid gears, that is the interference. And later on also we have seen how interference can be avoided, and like pressure angle we can increase somewhat, height of the tooth might be reduced, etc., etc. Those are some of the things we have seen. then the we'll see. Okay, what is the like minimum number of teeth? Okay, there is a minimum number of teeth which is required for avoiding the interference. So this minimum number of teeth which is required for avoiding interference. Okay, then we have seen that basically like when this interference happens in involute gears. Okay, and also we have seen like there is certain size relationship. Okay, and size requirement to it. Okay, so now along with that also, if there is like less than the required number in that particular teeth, then also like there is a process as that there will be interference. And that's actually from experiments it has been found out that there is a requirement of minimum number of teeth which is required to avoid the interference. Okay, up to this much I hope it's clear. No. Oh, Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what we have seen, the interference problem we need to avoid, which is really seen in case of which type of gear tooth profile? Involute gear tooth profile. Okay, not with cycloidal profile. So now, as I have said that there is this minimum number of teeth to avoid interference. So this there is small derivation for that, and this is your that this derivation. Okay, where I have right now here I have given the final, you can say, that the experiments only. Okay. Uh, Now this is your homework or assignment. You can consider do the complete derivation. Okay, so it's if you follow any book, you'll be able to get that. Okay, so just follow a book and complete it as a assignment. Okay, right now here I am giving this directly. So now, as I was saying that we need a minimum number of teeth to avoid the interference in involute care profile. This is generally we are talking about involute care profile. Okay, so now here right now we are talking about minimum number of teeth just to avoid interference. It is for both gear as well as for the pinion. Pinion is generally the driver or the driven. So pinion is driver. Okay, and this is the driven one. Or you can say this is generally is the smaller one. Okay, and this is the bigger one. So now for that, what are the different terminology that is involved? So like we know that the gear ratio that is given by what? The number of teeth in the gear, that is the bigger one, and number of teeth on the pinion. Okay, we can write G equal to capital T by small t. Also, you know R equal to mt by 2 because module equal to what? D by T. So from there, D is the pitch circle diameter. From there will be the this is T means twice, right? There is nothing but 2 times the radius. Okay, so from there we can write R to be equal to mt by 2. Now, as we are saying about, there are like two gear, one is the gear, one is the pinion. This is the bigger one, this is the bigger one, this is the smaller one. Okay, so for that the nomenclature also for denoting the gear. Okay, we are using the capital letters like smaller for pinion, capital R for gear. So now this pitch, this all those radius etc or diameter whatever we call about, this is with respect to the pitch circle. Okay, so always the pitch circle is the important one. This is the pitch circle radius that we are talking about, and this is for the gear. Okay, that is the bigger wheel. We can write M capital T by 2, and for the smaller one, this is M small t by 2. Okay, and now we know for the gear, that is the bigger one, gear wheel. So this is the maximum value of the addendum. Addendum, which is the addendum portion, the upper portion from your that one the pitch circle, or the lower portion from the pitch circle. Which radial distance is addendum from the pitch circle? It is up to the addendum, that is the upper portion of the teeth, or the up to the root portion. Which one is the addendum? Which one? Which one is addendum? Don't recall? It is the upper portion. If you go through the previous diagram, then you have seen that this is the pitch circle. Okay, this is the addendum circle. The radial distance between them. This one is the addendum. Okay, So addendum, this is A, capital A for addendum, okay, W for the wheel or the gear, the bigger one. This is the maximum value. It is given by mt by 2, okay, here, bracket, okay, root over 1 plus 1 by g. G is the gear ratio, whole into 1 plus z plus 2 into sine square pi. What is this pi? This is the which angle? Who can tell me? No one. So this is the pressure angle. Okay, pi is pressure angle minus 1. This is the maximum value of addendum. Also, addendum is given by 1 addendum coefficient. Right now, we are talking about for the wheel only. Okay, the coefficient, and this is for the wheel. And the minimum number of teeth on the wheel is TZ, that is for the wheel, T for teeth, G for the gear or the wheel, you can consider equal to 2 into A W, that is this addendum coefficient. This is the coefficient which multiplied with the module gives you the value of the addendum. Okay, this is the multiplication factor divided by this portion. Okay, so this is the expression for finding out the minimum number of teeth for wheel. Okay, you may note it down because this will be required while solving the problem. So similarly, for pinion, we can have the maximum addendum value A capital P for this pinion. Okay, A for addendum, P for this pinion. This is the maximum value. Okay, given by M small t by 2 will do. Now this is reverse. How we can recall? Okay, any one of the value if you recall. Okay, any one of the expression if you recall, then the other will be easy. So for the wheel, this is 1 by z. Okay, now here this 1 by z they become z. So this is the change only. Other things are same. So and definitely this capital T has to be correspondingly the small t, that is the teeth in the pinion that we have to consider. So mt by 2 whole into root over 1 plus, now this is 1 by g becomes z whole into 1 by g once again becomes z plus 2 sine square phi minus 1. And minimum number of teeth on the pinion, how we can get TP equal to same case. So this is the addendum coefficient, okay, for your pinion A suffix P. Okay, that means for the pinion, this addendum coefficient multiplied by the module will give you the addendum value for the pinion. Okay, so now it is similar to that only. So TP equal to 2 into this addendum coefficient divided by this portion. Okay, where AP, that is the addendum for the pinion, is this AP, this is the addendum coefficient for the pinion multiplied by the module. Okay, so sometimes this question is directly asked in some competitive exams and all. Okay, so you just have to remember that. So for two wheels of equal size with 20-degree pressure angle and whose addendum is equal to one module. So addendum itself is equal to one module. One module means what is the multiply factor here with m? This is 1. So this addendum coefficient, this value is, it means 1. So here the minimum number of teeth which is required on each wheel is your minimum number of teeth is value is 13, which is required to avoid interference. Okay, so just you can just note this down. Okay, these expressions which will be required later on while solving the problems. Once you note it down, let me know. I'll move ahead. All of you are there with me now.
Yes,
Yes,
sir.
sir.
Okay, you may note it down. Done. Done. Let me know. Hello. Hello. I'm audible or not?
Done, sir. Done, sir. Done. Audible, sir.
Okay.
Yes, sir.
Okay. Okay. So now next thing that we must know about the interchangeability of gears. Now interchangeability of gear means something like if you need to change one gear with other that and you're expecting that they are going to be proper match, okay, then that particular thing is known as the interchangeability of gears. Now sometimes it may so happen that you're working as a engineer in some company and all, okay. Suppose in some machinery some breakdown of gear has happened. So now in that particular case you need to either manufacture or you need to purchase a gear, okay, purchase a gear having certain specification. You cannot just say that okay, it looks like this or this means it only it has got, okay, then this kind of gear just give. So there are certain specifications and all which must you must know as an engineer. And also the thing is like if that particular gear is broken or something has happened to it, it is and if we are purchasing the particular suppose gear or replacing that particular gear, then it has to be interchangeable. So and that means in that case if they are interchangeable then you can be sure that they will match with the other gear properly. So now in general whenever the gears are the standard gears having suppose standard to profile and find like following the law of gearing, having all those modules and all design as per the design data, then generally they are interchangeable. And whenever a gear wears out, okay, or wearing out of the gear or sometimes breakage of the teeth, etc., etc. So that kind of thing happens. Definitely, there is a need of like replacing that particular gear, and gears of the standard dimensions can be very easily replaced when they get worn out because we already have all the standard data that is available. Standard it is being made with standard dimensions and all, okay, and the standard gears are also readily available. And if it is not, then the standard tools or ways or means of manufacturing the standard gears, okay, that is easy. Okay, so so that is the thing. Now when these gears will be interchangeable. Now if you need to have a interchangeability of gear, then these are some of the requirements. So they have the two machine gears, okay, they have the same module. They must also have the same pressure angle phi, okay. So same module M, okay, same pressure angle is phi, okay, the same addendum and they should be of same thickness, okay. So these are some of the requirements for gears which has to be interchangeable, okay. That means if you are going to replace it, then these things definitely these are some of the things that you must remember, and as per this specification only you need to call it, okay. So this manufacturing of gears of standard system, they are, as discussed previously, they are easier. Why? Because the standards, different standard cutters are already usually available for their manufacture. That's why it is justifiable. It is advisable then to go for standard system and find whenever required, as much as possible. Always follow the standards. Always go for standard gears and all. Okay, like always go for different standard in tooth profile. Okay, you may there is a depending on the work, okay, depending on the requirement, it's possible to have like uh, your what to say, like you can design your own teeth profile, and as per that, by following the law of gearing, like you can have conjugate teeth. Okay, so conjugate teeth profile that can be done, okay, which will match, okay, following the law of gearing. But that becomes somewhat complex, and this complexity is only justifiable when it's a very special requirement, when suppose that particular team, that particular solution, okay, having different term of teeth, okay, will give you suppose some very like complexity edge and all, then only this is advisable. Otherwise, like making it unnecessary complex is not advisable. Okay, so that's the thing. So so, after this much the theory portion for this particular gear person, okay, gear drive, that is actually over. So next we'll be solving some problems from the next class onwards, okay. So and after that we'll go for the next part of that particular module, that is about the gear trains. So normal gear or gear drive we have discussed. Now in the next class on next part, the gear train will be there. There also will be solving problems. Like first we'll see like different gear trains which are available, what is gear train, okay, where it is used, etc, etc. And then we'll go for like solving problem. And here also, okay, now as we are ready with different your the theory portion is basically over. So next we'll be going for solving problems. Okay, so is there any question up to this?
Sir, on 17 we have a class test 2, right, sir?
On 17th of this month.
December.
Okay, so that I think in your actually we have not got any notification for that. I think, but in the academic calendar, I think that is written, na?
Yes, sir.
Okay, so be prepared for that. Okay, you people be prepared for that. But till now, the official notification has not come. It might so happen that there might be some senses it might be there, or it might not also be there, because I think from 22nd or 23rd or around up to 3rd of I think your January, there will be your uh, winter vacation. Okay, that notification you have obtained, na? Yesterday, I think it was there. It
Yes,
was
yes,
out.
sir. Yes, sir.
Okay,
Yes, sir.
so in general, it is it happens now just prior to your whatever vacation etc. that is there. Prior to that, we generally have the class test and all. Okay, so this time also, as per the academic calendar, I think it will be there. Okay, but official notification, the final notification, it is not still out. Understood?
Yes, sir.
So if there is any question, any revision that you want, we can have, because today if we start solving the problem, the problems might not be over. So today we will not start the problems. Okay, numericals will do in the next class. Any question? No. If no, we'll move ahead and take the roll call. Okay, Nilupal,
Present, sir.
Shankar, absent. Arshisman,
Present, sir.
Rehan. Later on, Shankar will come and he'll say
Sir,
he'll
present,
guide.
sir.
Yeah, I knew. Arshisman, present, na?
Present, sir.
Rehan, Rehan, absent. Partha,
Present, sir.
Rishikesh Basamatari,
Present, sir.
Fermiki,
Present, sir.
Nahasul,
Present, sir.
Theza, Theza, absent. Rishikesh Nath,
Yes, sir.
and Emil.
Yes, sir.
Okay, so thank you everyone for joining. We'll meet in the next one.
Thank you, sir.
You complete that homework,
Thank you,
okay?
sir.
Consider that as a kind of assignment. Homework means assignment only.